Welcome to HCR Basic Training Course Chapter 3.2. In this chapter, we will learn about robot movement command and feature of each movement type. This chapter is very important because it contains many tips and skills to move your robot as you want. Let's turn on your robot and start this chapter. Before we move robot, you need to check your TCP setting value. Let's go to TCP settings screen and check your TCP and its position data. I recommend you to remember this data to understand next steps. And then, please click the programming menu to start the first step. We will only use this one command for this chapter. If you click the Move command icon on the Command tab, we can see 4 types of movement command. This one movement command contains 1 or 2 waypoints. By clicking the type icons in gray color, you can change the movement type of this command. There are 4 types of movement command: linear, joint, arc and circle. If you click the type icon, you can see Detail Parameter and Setting tab for this movement command. You can see an example image for each type on the right side of Explanation tab. And there are drop boxes for frame and coordinate setting and data field for speed and acceleration. Move linear command records the position data of your TCP from selected coordinate. Let's click Move J type. Move J command only records each angle of each joint and does not care the path of your TCP. So, we cannot expect the path, but this is fastest type of all movement commands. There are drop boxes for frame but not for coordinate function. Let's click A-type movement. This arc-type movement will make a perfect arc with your TCP. Move a command records the position data of your TCP from selected coordinate as same as L-type movement. But, you need to make 2 waypoints for one A-type movement, and path of your TCP will be a perfect arc which contains start and 2 waypoints. In this A-type movement, the waypoint just before this A-type movement will be the start point of this arc movement. Let's click C-type movement. This circle type movement will make a perfect circle and is almost as same as arc type movement. This command records the position data of your TCP and you need to make 2 waypoints for one C-type movement. The difference between A and C-type movement is the endpoint of the command. The endpoint of C-type command is its start point, but the endpoint of A-type movement is the second waypoint. Let's go to next step. I will show you a sample command and simulation for each movement type step by step. First of all, let's make a L-type movement and start point for this sample program. As you can see here, the start point will be home position of robot with linear motion. Please check out your TCP point. Your TCP has 100 mm length from the tool flange. Click OK button to save this position and input speed and XL data for this movement command. After this process, we need to check the frame and coordinate for this movement command. There are 2 kinds of frame: flange and TCP. Diffuse alt data is flange. Before you change the frame, please remember the position data. Let's change the frame from flange to TCP. After you change the frame, you can see the difference between Z position data according to your tool's length. As you can see on the screen, according to your choice for frame setting, ROTI will save different position data. And this will affect the path of your robot also. If you select TCP for the frame and make a circle type movement and run the program, the path of your TCP will make a perfect circle, but the path of your flange will not be a perfect circle. Because of this reason, I usually select TCP for this frame setting. Let's make additional waypoint to make a robot motion. Choose L-type movement and click Set button to activate manual control mode. In this case, I will move this robot parallel to base y-axis. After save the second waypoint, activate yellow image line to see the path of your TCP. You can see a yellow straight line parallel to base y-axis. Because there is only linear type movement, you cannot see curved movement in this program. Click play button to start your program. After you click the play button, the waypoint turns red color when your robot is moving to that waypoint. Even if you change the frame setting after you saved all program, there will be no difference between waypoint itself. If you want to check the real waypoint after you saved all positions, just select the specific waypoint and press move button of that movement command until robot reaches. Let's go to the next step of this linear type movement. I will add a new linear movement, and in this case, I will type the radius data for this L command. After I type radius data, you can see a new tab for middle and endpoint for this L movement command. That looks very similar to a curve movement command but has a difference. From start point, robot TCP will move linear but do not reach the middle point. The path of TCP will make a curve with radius, and after this curved motion, TCP will start linear motion and reach the endpoint. Let's click the set button for the middle point and move your robot parallel to x-axis. Click the set button for the end point and move your robot parallel to y-axis. After you click OK button for saving endpoint data, you can see two straight lines and a small curve which has radius between them. Let's click Apply button and run this program to see detail movement. As you can see on the 3D screen, your TCP does not reach the middle point and is making curve with radius. Also, TCP does not stop at the middle point. If you type small radius for this linear movement, your TCP will almost reach the middle point but does not stop at the middle point. We usually use this radius function when we have an unstoppable waypoint and also need to make a linear motion. OK. Let's go to final step of linear movement. There is a checkbox for continuous linear movement function, and this is only for linear motion. By using this function, we can make a continuous linear movement without any stop point, but it's pretty hard to make without trial and error. Let's add a new linear movement after the last move L. Click Set button and move your robot parallel to Y-axis. There are two requirements to make this continuous movement. The most important thing is that bent line is not available. If you don't want to stop at specific point, you need to make two straight lines with 3 waypoint. And then, you can pass the second waypoint without stop. Let's click Apply button. I can activate this continuous movement function but will not activate this time to see how robot moves. And then, let's make same speed for all linear motion in this program like me. After I click the run button, for every running cycle, robot moves but need to stop and go at the point just before the last waypoint if this program. Let's stop program and activate the continuous movement function for that waypoint. As you can see on the screen, you need to select the command just before the last one because the point you want to pass without stop is the endpoint of this command. Let's activate the function for this command and click Apply button to save changes. After you click the Run button, in many cases, you will see a motion profiling error message as you can see. And there's also a guideline to solve this problem. To use this continuous movement function, speed gap is not acceptable between two linear movement. Let's click OK button and find the command which is turned yellow color. In this case, you don't want to stop your robot at this point, and this point is the endpoint of the command which is previous of yellow 1. The important thing is that the speed of TCP when TCP is passing this point must be same or little higher than the speed setting value of command which turns yellow color. As you can see here, the speed setting is 1000 mm per second for yellow 1, and this means that acceleration is too low or you don't have enough space for acceleration to reach 1000 mm per second. To make it works, you have 3 options. The best and easiest way is reduce the speed of yellow command. Or you can increase acceleration value or distance for acceleration of previous command. Even if I've reduced the speed value of yellow command but it does not work. But at this time, the last command is no longer yellow color and previous command of last command turns yellow. That means that speed of your TCP is much higher than the value of last one. So, let's reduce the speed value of previous one also. I will use same value this time. Finally, this program can run without error, and you can notice that speed of your TCP at the end of this program reaches 500 mm per second. You can see your robot does not stop at the point as you set. If I change the speed and acceleration values like this to increase the total speed, you may need to try many times to find a fine value for specific motion. I recommend you to focus on yellow color because that yellow command has an error and also key to solve this motion profiling problem. I know that it is very hard to understand and use this continuous movement function, but Rodi guarantees that robot will move at specific speed as you set. It is very hard to find appropriate speed and acceleration value, but if you able to do that, constant and controllable speed will help you to make stable automation process like welding. Now, let's try to make continuous movement at the endpoint. Click the last or second link type movement command and activate the continuous movement function and save the program. In this case, because of tilted angle between straight lines including that waypoints, you will see motion profiling error. It's the end of linear type movement command. Let's learn about other types of movement. Click Move command icon and select Join Type Movement. In J-type movement, there is also frame selection field like other type. But there is no coordinate field because J-type movement records only angle data, not TCP position. Click Set button and move your robot parallel to Y-axis. After you click OK and Apply button, you can see a new path for this J-type movement. You have to be aware of this path because this is not a straight line and undetectable. If you use maximum speed and acceleration value for J-type movement, you may see the fastest motion speed because J-type command rotate every joint at the same time. Let's go to the next step. Acre type movement is very similar with L type with radius. We can also select frame and coordinate for this command and need to make two waypoints to make an arc. Let's make two waypoints for this command. After you make 2 points, you can see an arc in the 3D simulation screen. Click Apply and Run button to see the motion of your robot. If you click the arc type movement and change the type from A to circle, you can easily change the type without error. In this case, you can see a perfect circle instead of arc. The difference between acre and circle movement when they have same 3 waypoints is the final destination of TCP. When arc command executed, your TCP will stop at the waypoint 2, but when circle command executed, your TCP will stop at the start point of the circle command. Let's see the difference on 3D simulation screen. As you can see on the screen, your TCP makes perfect circle for 2 times as you command and stops at the start point of circle command. For linear command, we can use variable or relative movement to make a waypoint. You can also use relative or variable to make a waypoint for joint type movement command, but in this case, variable must be a joint type. Let's make a new linear movement to make a relative motion. If you select relative movement, you can see a new screen for relative movement. First of all, please click from button to save a base point of this relative motion. Move your robot with manual control mode or just save if robot is already at the base point. And then, click to button to make a relative motion. Click set button and move your robot as you want. After you click OK button, you can see a calculated distance on the screen. Let's copy this relative motion and place this command just after the other movement command. After you paste the relative movement command, you can see copied relative motion on 3D screen. And let's focus on the name of these command. Their 2 commands have same name and you can see a red line on the command icon. Let's click apply button and run this program. Now, you can see 2 relative motions which have same relative distance from each base point. For circle and arc command, we can also use variable or relative movement to make a waypoint. If you select variable for such a command, you can see a drop-down menu to select one of movement type variables. To use variable for movement command, we need to make a position or joint type variable first. Let's make a joint and position type variable, for example. After you make these variables, you can see these variables in the drop-down menu in movement command screen. The next step is changing the name of commands. Let's add new movement commands and change the names. If you type a name which is already used for other command, you can see a pop-up message like this. In this case, you can load all properties of other command for your new command by using the same name and clicking the OK button. After you click OK button of this pop-up, you can see a same position data for movement command. But please beware that speed and Excel data are not copied. And also, if you move your waypoint for one of the commands, other commands which uses same name will be changed according to changed one. If you click one of the shared commands, you can see a red lines on their command icon. Congratulations! You've finished all steps of this chapter. Thank you for your concentration. See you next time.